In today's class, this is day 44 of 50 days of tutelage, by the way. I'll be talking about light wave. So you remember in our previous class, I introduced you to the concept of wave, and I told you that some waves require material medium before they can be propagated. Those are mechanical. And then I said some don't require material medium. Those are electromagnetic wave. They can even travel through vacuum. One of those electromagnetic waves is light. And I'm going to be giving you a lot of things, a lot of details about light wave in this video. So the first thing I'm going to be talking about is that light is actually what gives the sensation of vision. So light gives the sensation of vision. And what do I mean by that? So one would think that the necessary condition for you to be able to see is for you to have eyes. But if you have eyes in the absence of light, then you will not be able to see. So it is light that falls. So if this is your eyes and this is the object that you want to view, then a certain amount of light falls on this object. So when this light falls on this object, it is reflected back and your eyes is able to see it. So this is the way light works. It gives the sensation of vision. But beyond that, we have a lot of other things to talk about light actually, which is why we have some objects that produce light themselves. They naturally produce light themselves. And some objects, they depend on other sources of light and they reflect light from that source. So we have what we call luminous objects and we have non-luminous objects. So if an object is categorized as luminous, that means that it emits light by itself. It emits light by itself. But if an object is categorized as non-luminous, then what they do is that when they get light from other source, they reflect the light. They reflect the light that they get from other source. So if I thought they will give any form of light or they will be shiny in any way, they would have to depend on another source of light to emit light. So examples of luminous objects like the sun, the stars, these two guys are actually natural sources of light because they emit light by themselves. You also have so many other examples. You can always check that up. Then you have bulb, electric bulb, incandescent bulb, lamp, and all of those things. Those are natural sources of light. But some that depend on them, that is, they need to reflect light from some of these sources, like the moon. The moon is also a natural source of light, but it is not a luminous object. It is not categorized as a luminous object. It is non-luminous because it reflects the light from the sun. It cannot produce light by itself. So like a piece of paper as well, if you shine light on a piece of paper, it will reflect the light back, and that is going to be a source of light, but it is non-luminous. Mirror, and so on like that, they are sources of light. So we have the luminous bodies and we have the non-luminous body as well. Luminous, they produce light themselves. Non-luminous, they reflect light from other sources of light. Then we have, let's talk about how light is being transmitted. So light is being transmitted such that if it passes through a body, if it passes through a body, that is, it got to this place and it's able to make it out. Then sometimes it gets to this body and it's not able to make it out. Instead, it bounces back. So this one continues. This one came this way and it bounced back, or came this way and it's able to make it out, but not that enough. It was able to make it out, but not that enough. Just a little bit of it was able to make it out. So let me just draw this here. Yeah. So when we have these three different types of bodies, we say this one is called transparent body. Transparent body. This one is called opaque body. So this body is said to be opaque. Permit me to rewrite that, please. So this body is said to be opaque, and this one is said to be translucent. This body is said to be translucent. So when light is being transmitted through a body, if the light makes it through the body, that is, most of the light that enters the surface of the body is able to make it out. On the other end, Then we have what we call transparent bodies. Then we have opaque bodies. These opaque bodies, when light falls on them, they reflect the light back. That is, they allow almost none of those light that is falling on them to pass through them. So we call them opaque objects. And then translucent, they only allow light to pass through them sparingly. So for this one, you can easily see through them. For this one, it is impossible, very difficult to see through them. And for this one, you struggle to see through them actually. So example of transparent body, like a glass. Example of opaque body, a mirror. So you can see a glass is not coated, but a mirror is coated. And then translucent body, maybe you have like shower curtains, or you have a piece of paper that oil has, like there's an oil drop on a piece of paper. That point where there is oil drop on the piece of paper is going to be a little bit translucent. So that is that about transmission of light. So before I go further in the transmission of light of a thing, because I will talk about the rectilinear propagation of light very soon. So the next thing I want to talk about is the concept of ray and beam of light. So we have ray of light and we have beam of light. So what is ray of light? A ray of light is simply uh, an imaginary line that shows the direction or path along which light energy is flowing. So when you say a ray of light, so if I shine my light in this direction, so if you notice I've been using arrow ever since. That is just me trying to like show you the path where the light energy is flowing. So a ray of light is like a kind of line that we use to represent the flow of light. And the collection of these is what we call beam. So when you have more than one, so you have several of these, one, two, three, four, five, and many more like that, then you call it beam. The collection of rays of light is called beam. And so we have what we call convergent beam, we have divergent beam, so we have parallel beam as well. So if they are like this, then you have what we call parallel beam. If they are like this, you have what we call convergent beam. And then if they are like this, so you call this one divergent beam. So these ones, they emanate from a source and they diverge thereafter. These ones, they come from a source and they come all the way from about and they converge at a given source. These ones, they emanate from different sources and they keep going in that path. So that is the between ray and beam of light. Next thing I want to discuss, and this concept is called the concept of rectilinear propagation of light. So I'm just going to write that down there. Rectilinear propagation of light. So what is this phenomenon? This phenomenon simply tells us that light travels in straight lines in a uniform medium. So basically, just like I've explained that we have ray of light and we have beam of light. So if you are to visualize the traveling of light, so we see that light travels in paths like this. I'm just going to copy this and paste it severally. It is not taking more time. So light travels in straight lines, as you can see here. I think I should just limit it to this 4 only. That would suffice. So light travels in straight line in uniform medium. And this phenomenon can be established through 3 ways. So the formation of eclipse. So I will talk about the formation of eclipse. I will talk about the formation of shadow. And I will talk about the pinhole camera as well. The pinhole camera. So let me start with the formation of shadow. So what happens is that when light hits an opaque object, so let's say there's an opaque object in the path of this light now. So this is how we know that light actually travels in a straight line. The first thing is that if light should hit this object, so let's say the object is there, and this object is an opaque object. So what we observe is that on this other side, light will not be able to make it to some path. And so if you have a screen on this side now, so what happens is that this particular light now, some of it will make it down here. Some of the light will make it down here. So look at this. Some of the light will make it down here. But look at this particular one now. When it hits this place, it's unable to make it out here. And in this region now, you have what we call formation of shadow. Formation of shadow. So shadow is going to form in this region like this. And why is that so? It's because this opaque object is blocking the path of light. And because light travels in a straight line, it's not allowing this light, the portion of light that is falling on it, is not allowing it to be able to make it out of it like that. So that is what the formation of shadow is about. And you see, for shadow, shadow is actually synonymous to darkness. When we say shadow, even shadow, eclipse, these two guys, they are synonymous to darkness. So it's called the absence of light. So the fact that light is not able to make it to this point now on this screen, then we say there is absence of light, which is what? Shadow. So whose shadow is formed? The shadow is going to be in the shape of this guy. By the way, the shape of the shadow is not only dependent on the shape of this guy, it's also dependent on how the light is incident and the angle which the light is incident on the surface as well. So we have two regions. We have what we call the umbra regions, and we have the penumbra region. Now, umbra region is a point of total darkness, while penumbra region is a point of partial darkness. So when shadow is formed, so the region where you have complete shadow, where no light from the source reaches at all, so that is what we call the umbra region. But you notice that a little bit of light can actually bounce around the edge, and then you don't have too much thickness of darkness. So you don't have too much thickness of darkness in that region. So this region now, or somewhere around this place, yeah, they are a little bit dark, but they are just faintly dark. So that region is called the penumbra region. That is a place where you have partial darkness, and where you have thick darkness is known as the what? Umbra region. So that's basically the formation of what? Formation of shadow. Like I've explained, when you have opaque object in the path of light, and then the light source is unable to what? Is unable to pass through that object, and a kind of light is now formed around the shadow that is casted on the other side. So because some of the light passes through the edge of that opaque object, they pass, around the edge of the opaque object, but they cannot pass through it. So therefore, shadow is formed on the other side. And then if you want to have a sharp shadow, you want to have sharp edges around your shadow, you don't want to have a blurry kind of shadow, then you need a small light source. So with small light source, then you have what? You have a sharp one, such that you most likely will not have penumbra. You will only have umbra region. But if you have like a big light source, so a big light source like this now, so the light source is bigger than the object itself, so there will always be a kind of penumbra region. So a point whereby light kind of reaches there, but the darkness here, so it's a mixture of darkness and light together. So it gives us a penumbra region. But if you have a small light source, for instance, let's say just we are considering just this single light source now. So you can see that we have a what? A shadow around it. Even if there is a kind of ray of light that is making it out of this place, there will be so inconsequential that the darkness will just, totally overwhelm the light sensation around that area. Then we have the formation of eclipse as well. So for eclipse to be formed, we have the sun, we have the moon, and we have the earth. These guys, they constantly move around. So we have the earth as well. Now, of course, the sun is there, not moving. Sun, I meant sun. So this is the moon and this is the earth. So this one is revolving around this one is revolving around this. So at a point, there's a kind of alignment such that the three bodies, they line up in a straight line like this. So I want to show you something here. These people are on earth. And if they are on earth, what happens is that normally when you're facing the sun, you're supposed to be in the day and you're supposed to see the daylight. And when you are away from the sun, then you are in the night. So meaning that these people here, they are supposed to be, this is supposed to be their day. And these people here, this is supposed to be their night. So these people are supposed to experience daylight. But the problem now is that there is somebody in the path of this guy, which is an opaque object. So instead of ray of light to now go like this, so you have ray of light going from this place to this place. You have ray of light going from this place to this place. So you now realize that rays of light that are supposed to actually make it down here during the day will not be able to make it. So these people are supposed to experience daylight. So therefore, their daylight is being denied. Where should their daylight come from? Their daylight should come from the sun. So because their daylight should come from the sun, and therefore they are now being denied from they are now being denied daylight from the sun, then that implies that they are experiencing darkness of the sun, or otherwise what we know as the eclipse of the sun. Eclipse of the sun, also known as the solar eclipse. So eclipse of the sun happens when the moon is in between the earth and the sun. So the moon is blocking the path of light that is supposed to be reaching the earth from the sun. But we also have the one that we call annular eclipse. That one, I'm not going to be discussing much about it in this video. This video is meant to be short and it's getting too long already. So annular eclipse is actually when you have a kind of ring of light formed around the earth. Why? Because the intensity of the light coming from the sun is so high, and also the ray of light, they kind of intersect before they reach the earth. Then you have what we call the annular eclipse. So that's just the basic thing I'm going to discuss about that. Then the other one, which is called the lunar eclipse. Now, the lunar eclipse, now, from what you know that at night, what gives light is the moon. So therefore, automatically, let's say we have the sun here, we have the earth in this place, and let's say we have the moon here. So what happens usually is that when ray of light comes from the sun, so let's just draw a single ray, and it gets to the moon like this, the moon reflects it back and it gives it as a form of light in this situation. But at a particular point in time, let's say this moon is not here. So the moon is somewhere around this place. So the people here that are at night, so you know already that these people, they are in their day, and these people here, they are in the night. So what happens is that the people here that are supposed to experience the light coming from the moon, from what we know, light is supposed to hit the moon around somewhere here, somewhere, whatever. So the moon could have been here, any of these places. So, but it's here now. The earth is completely blocking the ray of light that is supposed to hit the moon and be reflected to the people at night. So these people at night, they will not be able to see the moon at all. And so therefore, what they are experiencing is that the moon light they're supposed to experience is not there. The absence of moonlight is synonymous to darkness of moonlight. Therefore, what they are experiencing is eclipse of the moon, also known as lunar eclipse. So they are experiencing the lunar eclipse because they're supposed to experience moonlight, but now the earth is already blocking the ray of light that's supposed to come from the sun for the moon to reflect. So therefore, you have eclipse. Now, one student already, there was a time a student asked me in the classroom about the fact that, so, and that was a very brilliant observation. So I explained so much that they begin to understand the old idea of eclipse. Do you know that we can actually have what we call eclipse of the earth? Yes. For people living here on the moon, they can also experience eclipse of the earth as well. So I'll give you that as an assignment. Figure out what would it be like, what exactly would be the situation for these people to experience eclipse of the, because if the moon can give moonlight, moon is an opaque object, it reflects light from the sun to give moonlight, then the earth as well can reflect light from the sun and give earth light to people living on the moon. So think about that. So that's that for eclipse. Now for the pinhole camera basically use the concept of rectilinear propagation of light to produce images. So what happens is that we have a box like device, and this box like device there is a pinhole that is created in it. So I'm just going to, yes, I'm going to use this to create the pinhole. Yes. So here you have a pinhole, and on one side of this box you have a screen. You have a screen here. I don't want an arrow. You have a screen in this place. So let's call this a screen. Then you place a light source here. There's a light source. Then the object is here in front of the pinhole. So light is going to enter this place and therefore forming what? A sort of image. So I'm not, because of time, I'm not going to be saying too much. What we notice here is that the kind of image that is formed here is always real. So what is real image? Real image are those that can be caught on a screen and light actually pass through them. The other one we have is virtual image. Virtual image, light does not touch them actually, and they cannot be caught on a screen. So this is real image, and the image is also going to be inverted as well. So that's what we noticed about the pinhole camera. The image is real, it is also inverted. Now, the image can be blur and the image can be sharp. What determines that is the size of the pinhole. If the pinhole is small in size, then you have a sharp image. But if the pinhole is large, if it is large, then you have what we call a blurry image. And so what happens is that if you have a large pinhole, so let's say this pinhole compared to this pinhole now. So you notice that we can actually have several of these in this place, like let's say 10 of these in this place. So these 10 small pinholes, we kind of form their own individual images. And when they form their own individual images, there is a sort of overlapping, and that's what leads to the blurriness. Unfortunately, when we have sharp images, we may not necessarily have them to be bright, because brightness has to do with the amount of light that is entering the pinhole, the box. So we need large size pinhole to produce bright image. So that enables, what would I call it now? That enables the image to be bright. But we have realized that large pinhole will make the image to be blurry. So how do we solve that problem? What we can do is that we can increase the intensity of the light. So if you increase the intensity of the light, or you perform the experiment in a controlled area, maybe let's say you trap all the light in this place with, let's say, a dark object. You trap all the light in the environment so that more light is going to be able to make it in there, and you are also still going to maintain a pinhole. That is the only way you can produce a sharp and also a bright image. So advantage of a pinhole, a sharp image, but the image is not bright. Advantage of a large, it's no longer a pinhole, of a large hole now is that you produce a bright image, but the image will be blurry. So you've seen how we can actually mitigate that. We still have a lot of things to say, so I'm just going to do a quick thing on reflection and refraction. Just a quick thing on reflection and refraction. So what is reflection of light? Reflection of light is simply the bouncing back of light whenever it hits a surface. So when you have a surface like this, and light is incident on it in this manner, so what happens is that the light actually bounces back as well. And so we always imagine something like this, which is called the normal ray. So normal ray is simply a perpendicular to the place where the surface where light is being reflected from. So this normal ray, there's an angle that the incidence ray will make with the normal ray. We call it angle of incidence. See, this angle is also the same thing as the angle with which the light will bounce off, which is the angle of reflection. So we say angle of incidence is the same thing as what? Angle of reflection. So in other videos, I'm going to be talking more about reflection. Now, the next one is refraction. So refraction is simply when you have let's say there's a line of separation, and let me draw a normal ray just between this guy. So let's say this is a medium, let's call this medium A, and let's call this medium B. When light actually travels from this surface, medium A, when it gets to this point of separation, the light will pass through it. Of course, this object is a transparent object. Light can pass through it. So light now determines whether it's going to change direction or not. Of course, if there are two different media of varying density, then that implies that this light will change direction. The only problem is that will the light move towards the normal? That is, will it move towards the normal like this? Or will it move away from the normal? That is, based on the normal path that is supposed to, normally this is the path that is supposed to follow, this straight path, but it's going to bend. So changing direction and changing speed. So will it bend away from the normal path, or will it bend closer to the what? Normal ray. Now, what determines that is the density of the medium. If if you have it like this, what it implies is that this medium is actually a what? A denser medium than the previous medium. So when you're moving from a denser medium to a less dense medium to a denser medium, the light ray will bend towards the normal. But when you're moving from a denser to a less dense medium, something like this, the light will bend away from the normal. The light will bend away from the normal. And as you can see, the normal path that this light was supposed to follow, this was supposed to be the normal path that the light was supposed to follow, this right here. So if it is from denser to less dense, so let me just change that real quick, please. So if I'm moving from denser to less dense, this is what happens. But if I'm moving from a less dense to denser, this is what happened in that medium. A less dense to denser, and then a denser to what? To less dense. This is what happened. And that's basically what refraction is about. Of course, there are other things that I would have said about refraction, but because of time, I won't be able to continue. So by the way, that will be the end for the class today. If you have not subscribed to the channel, I will urge you to do so. And make sure you like this video as well. I'll see you in the next one. All right?